Hello, welcome everyone. I'm going to give just another few seconds for people to start trickling in. And as people are trickling in, just want to make sure you're in the right place. So you're here for a Project Wild webinar where we're celebrating Earth Day all month long. And today's special presentation is on soil. And we're going to talk about how soil impacts a greater ecosystem. And I think we'll go ahead and get started. So next slide, please. Is the official welcome slide, right? And to remind you again that we're talking about soils today. So welcome everyone. Thank you for joining us. And next slide.
One second. Here we go.
All right. So just a little bit about Project Wild in case you're not familiar. Project Wild has been around since the mid-1980s, so a long time, and we're a pre-K through 12 curriculum and professional development program, and we operate on a national and even international scale. We have a number of guides available for you. Flying Wild, which focuses on birds, Aquatic Wild, which focuses on aquatic wildlife, Growing Up Wild, which is our We Wild Ones curriculum, so ages 3 through 7, our Project Wild guide, and then our most recent guide is Project Wild Climate and Wildlife, which really focuses on how climate change is impacting wildlife populations. And if you have any questions or want to know more about Project Wild, you can visit www.projectwild.org. Next slide, please. As we're getting started, please do introduce yourself in the chat and say hello and let us know where you're from. And while you're doing that, I'm going to introduce our guest panelist for today. So our guest panelist is Kalina Vatave, and Kalina is our agricultural policy manager here at the Association of Fish and Wildlife Agencies. And she studied soils at the University of Georgia before working as a soil conservationist and obtaining her master's in environmental policy at Johns Hopkins University. And now she spends her days advocating for fish and wildlife and policies such as the Farm Bill. Food production has wide-ranging impacts beyond the soil and the field, and she can't wait to share that with you. And she's also a self-proclaimed dirt nerd, right? Do I have that right, Kalina?
Yes.
All right, welcome and thanks for being with us today.
Great, thank you, Elena. I see there's a hand raised. I don't know if that's a technical issue you want to address before we get started. Maybe not. If there's any issues, feel free to toss them in the chat or in the Q&A, and we will get that sorted out for you. So without further ado, we'll get started. So like Elena said, my name is Kalina, and I'm here to kind of present to you this afternoon all things soil. So I'm really excited, and we can kind of jump into things. So first things first here is, soil supports the world. That's what I like to say. Soil is everything. We learn about organisms at the smallest scale possible, all the way through the largest at a global scale. And we can do the same with soil. So soil plays a critical supporting role at all of the scales, but is often overlooked as minor parts of other systems that we study. And when we ground our thinking with soil as the foundation, we can easily see how our biological world interacts with the air, earth, and water that's all around us. But before we kind of get into that, I want to address, what is soil? A lot of us think of it as just the dirt underneath our feet, but there's so much more to it. There's so much uniqueness that a soil can have. So we're going to dive into that just a little bit. And uncover the secrets. So first here, we have soil size. So soil is basically made up of minerals. I like to think of them as teeny tiny rocks, and they come in different particle sizes that we can classify. The largest would be sand. Next would we have our silt, and then clay. Out in the field, we like to say you can see sand, you can feel silt, and you can't do any of those with clay. So all soils are made up of some kind of proportion of these particle sizes out of different minerals, and that's how we get all of the different soils that we get across the world. And so that particle size contributes to what we call the soil type. And so the soil type is what you would kind of recognize as soil. You know, we have red clay where I'm from in Georgia, you know, on near beaches on the coast, we have sandy soils. So that proportion of sand, silt, and clay creates our soil type. And that soil type is really important when we're looking at agriculture, when we're looking at soil for building, foundations, septic systems. Soil type really comes into play there. And then after we look at soil type, that kind of factors into the mineral or the solid portion of what I really like to think of as the living soil that has all these other components. So the mineral part is about 45%, and that is what those sand, silt, and clay particles comprise. And then the next 5% would be organic matter. And so that's kind of the solid portion. So that organic matter can be decaying plants, it can be insects, it can be roots. There's lots of things it can be, anything from, you know, organisms all the way down to completely decomposed plant material falls into that organic matter portion. And then the other half of soil is air and water. And that varies a lot depending on, you know, if you water your garden every day, it's going to be a lot more water than air. But when soils are kind of in their natural state, it's somewhere between half and half air and water for that non-solid portion. So that's another area where we see uniqueness in soils, and that, you know, kind of components lead us into the horizons of a soil. And so each horizon is going to have a different makeup of air, water, and that mineral component and organic matter. They're going to have different textures that fall in that clay triangle or the soil triangle, and different particle sizes as well. And so that all just comes from, you know, layers and layers and years of, you know, earth moving, thinking geomorphology as things erode, as light changes, we get all these different layers in the soil. And so this top O through, you know, B horizons, it would be things that I like to think of as diggable. You can get in there with a shovel or with a trowel, you can plant things in there. And then below that, we have what we think of as our bedrock. And then the substratum below that, which is not always diggable. But I like to look at the horizons like this, and you can see from bedrock up how soil is created from that rock and other material that's deposited on it. And it can tell a really interesting story about an area. So that's what soil is. That's the, you know, that's the basics. That's how we understand it from a scientific level, just looking at the soil. But in reality, there's a lot more to it. And that's all great to know, but we really need to know, you know, what is healthy soil? What do we want soil to act like and look like, and how should it be? So the NRCS, or the Natural Resources Conservation Service, a government agency, defines healthy soil as the continued capacity of a soil to function as a vital living ecosystem that sustains plants, animals, and humans. So I want you to think of soil, healthy soil, as a vibrant city. It's alive. It, you know, needs air, it needs water, it needs nutrients, just like, you know, people do who live in that city. And so let's see. While we'll get more into what healthy soil can do, for now we're going to look at what it is and what's important and how we get there. So we can go ahead and look at the principles of soil health here. And right before we dive into them, I just want everyone to kind of look at these top two soil side by sides at the top, and just kind of think to yourself, which one looks healthier to you? Which one would you want in your farm or your garden if you were, you know, growing food for your family? While you kind of think about that, we'll dive into these principles to see if we think those are being achieved. So the soil on the right has gone through what we call conventional tillage for many years. This is where farmers prep their fields before planting by turning over the soil and loosening it up. Leaves a beautiful blank canvas of earth to plant in, makes it really easy to get that seed to soil contact. That's super important. And that's how many people have been farming for many years. And then on the left, we see a soil that has largely been undisturbed in terms of farm equipment. The crops here were planted with what we call a no-till drill into the last year's crop residue. So we're going to kind of see which one we think follows the principles of soil health. So we'll start with maximize soil cover. You could start anywhere, but I like soil cover because we have another photo right here to kind of highlight that. And so looking at the photo on the left, we see this is a soybean field, and on it we have corn stubble from the previous year's crop. And so that's kind of what we're talking about when we look at soil cover. We can have that dead residue, or another component of that would be like a living cover, which could be some kind of crop or clover between rows, or just between crop seasons, like over the fall or in the spring before it's time to really plant that cash crop. So cover is really important for a couple of reasons. The biggest one would be that it prevents erosion. So soils can be pretty fragile. And what we talked about before with the sand, silt, and clay, those soils are held together by aggregates. And so when the soil's dried out and it's vulnerable and uncovered, those aggregates can break down more easily as things rain or wind picks up. So it can experience wind or water erosion. And so that's something we look at when we think about soil cover. I also like to think about soil cover directly tied in with maximizing living roots. So like I said before, they're all kind of tied in together. The living roots really help strengthen those soil aggregates, thinking, soil like clumps or globs, whatever you want to think about it. It's little chunks of soil that stick together. They maintain their structure, which is really good for the health of the soil. It helps water flow through it and not just over it. So those living roots are really important. And so that can also be a component of that soil cover as we keep living roots in the ground. They're typically accompanied with leaves above the ground, and that keeps that soil from washing away or blowing away, and simultaneously builds that soil structure underground with those living roots. And so some people will wonder why we're thinking about living roots. When we're looking at farming, it's not uncommon to plant something in the spring, so we'll say April, soybeans, for example. That might be a little early, and then you'll harvest it in the fall or late in the summer. After that, you could have nothing in that field until the next spring. So that could be 6 months of uncovered soil that's sitting there, no roots in the ground, which is not following these principles of soil health. And so living roots is really something that a lot of farmers are not used to. Keeping living roots in the ground would look like trying to plant something over winter. Even as those plants die off because of snow or cold, those roots are still in there providing organic matter and decaying as those plants die off, getting the soil ready for the spring with lots of nourishment. And that kind of brings us into this minimize disturbance would be our next concept. And this kind of goes back up to that photo where we looked at the two different soils and we said, okay, one has conventional tillage, the other was planted with a no-till drill. And you might ask how I know that, because I know what they look like. Those kinds of farming methods can result in very different looking soils, even if it's the same soil type, soil texture, all of those things, they can look very different because of how the soil's been treated. So I think the best analogy for thinking about disturbance is, our homes are made of wood. And so when these homes are knocked down, what happens? They're weak. If there's tornadoes, if there's storms, that's what tillage is basically doing to the soil. It's destroying that structure. All of the pieces are still there. In theory, those minerals aren't being lost because of tillage, but they're losing their structure, their connection to each other. Those aggregates are breaking down. And that soil can get compacted. And so that is kind of around the principle of minimizing disturbance, is to keep that soil structure there and let it function and build up that kind of healthy ecosystem that's within it. Soils have lots of microorganisms in them. And I think we'll kind of get to that on not the next slide, but the one after that. But there's lots of life in soils. And so when we disturb them, we are compromising all of that life. We're drying out microorganisms, we're removing tunnels for earthworms, potentially closing burrows for small mammals. And so that's kind of where the minimized disturbance impacts more than just the soil structure. It also destroys that soil ecosystem, which brings us into maximizing biodiversity. Just like you and me, if I was told to eat corn all day, every day, or bread all day, every day, I would not be a happy camper. Soils are the same thing. They don't want to live in a sterile environment. They don't want to be free of weeds and bugs and things like that. They want it all. A healthy soil has lots of critters in it. It has lots of plant roots of different kinds, providing it different things. There's lots of symbiosis that goes on when plant root exudates. They kind of help the soil stick together, and then the soil gives the plants nutrients, and it all kind of goes both ways. And a crop like soybeans provides nitrogen to the soil, but if you planted that all the time, it wouldn't be a super positive thing for your soil. It would not need it anymore. It would need something else. So that's why frequently we'll see corn and then soybeans planted because of that trade-off with the nitrogen. The corn gets to take the nitrogen, the soybeans supply it, all thanks to the soil. So that's kind of where that maximizing biodiversity comes in. And so we see this on even a more advanced scale. When we look at cover crops, we can plant, let's say, a field of clover over the winter if we want to, but what if we turn that clover into clover and another grass, and then something like a radish that provides a lot more diversity to the soil. You'll see a lot more benefits in terms of improved structure, improved water infiltration, and all of that kinds of things. So my favorite image when I think of biodiversity is cows grazing field radishes to help turn up the soil in the early spring as snow is thawing. And I think that's the best place to take that there. And so that kind of takes us into a little more like agriculture conversation of what, different crops, different cover. One misconception I think people have about their food systems and their soils that they're impacting is knowing what crops look like on the ground. And so we just looked at some soybeans, and now here on the left, we have corn. In the center, we have a pasture, and on the right, we have broccoli fields. So none of this soil health concept is one size fits all. Thinking back about how food connects back to the ecosystem it's grown in, we have to think about what makes each crop different. What is the leaf structure? What is the plant structure? Where does the fruit come from? So in this first image, I said we have the corn here. Most corn is not corn for people that's grown. Most corn grown is for animal feed. So that's why I put a little chicken on here just to remind us that most of our crops are grown for other animals that then we can eat. But if you notice like how much space there is between each row of corn here and what that soil looks like, does that soil look healthy to you? When I look at this as, someone with a background in soils, I see a little bit of residue, which is a positive thing. I see big clumps of dirt, which means it was probably really wet. So they tilled up the field, they turned it all over, mixed in that residue. I see crusting from rain because there's not enough cover on it. There's a lot that we can see just from this image that they could improve on. But the hard thing to think about is that balance of what can a farmer do versus what do we want the farmer to do? It's not always practical in terms of equipment and things like that. So when we think about where our food comes from and what we want the future of our food to look like, it's important to consider, what can farmers do these days? So that kind of brings me next to our pasture. I like this photo because you can't see the soil. This is an excellent image of soil cover. All of the soil health principles apply to grazing and livestock as well. So here we have a lot of grass. I don't see a lot of diversity in the grass, but it's certainly, there's some, and we can't see the ground. So we're hitting at least 2 big components, 3 if you think about the roots of cover right there. And then we hit 4 if we are not disturbing this grass too often. Disturbance from cows is usually not as big of a deal as disturbance from equipment, but too much can still be a bad thing. And then when we look at this last image, thinking about the soil between these broccoli rows. So we have a lot of cover, right? Within a row, the leaves are really big. We're protecting that soil there. Between the rows, there's nothing. There's a couple leaves, so not a ton of residue. It looks kind of cracked and dry. So a lot of places where they are working on soil health in vegetable fields, they will lay down hay or straw, or like mulch and things like that in between the rows to kind of reduce that erosion. But when we see things like this on the broccoli fields and really a lot in the corn fields, we have to think about what happens when we lose soil. And so, soil holds on to nutrients that plants need. And so when that soil washes away from wind or water, we're losing those nutrients with it as well. And we can kind of talk more about where those go in just a second. So we talked about what healthy soils are, which is great. I am hoping that you have a better understanding of what a healthy soil looks like, why we need it. And that's what we're going to get into here. So why do we need healthy soils? So at all levels, we'll kind of go through them. I might lump a few together here, but we will kind of go from small to big. So at the atomic level, soil provides nutrients to plants, plays a role in the carbon, nitrogen, and water cycles, which is really important if you think about, what do you want from your food? We want food to be healthy. And so in order to have healthy, nutritious food, we need to have healthy, nutritious soils that have all of these nutrients and vitamins and minerals in them. And this is kind of how we translate, food nutrients from minerals. When you look at, calcium or sulfur, we see them in geology labs. You can look at what these rocks look like, or what, components of these look like in rocks. Those are all things that contribute to soil. And so that's what we can get out of soil. And that's, why we need healthy soil at that kind of atomic level. As we kind of move up to the organism level, many organisms rely on soil just for habitat and their food source. So these range from tiny microbes to burrowing animals to all the bugs, fungi, and plants that kind of fall in between. It's a medium for plant roots. It's where things like to lay their eggs and live and raise their young. But also just the biome of microorganisms and soil is just amazing. What you can find in there. It's pretty cool. I could say so much, but I'm limited on time, so I won't geek out on that too much today. But as we kind of move from the organism level or community level to, or here we'll go to the population level, healthy soil over a landscape extends the benefits to even more organisms. So we just looked at what mammals can be, or what animals are using the soil for their own habitat. But when we look at, the community and the populations, we're seeing other animals who maybe don't live in the soil. They don't spend all their time there, but that's where they find their food. So, things like birds and other mammals can find their food either in the soil or on the soil, hiding in, those plant roots. So it really creates a full system, the full food web that can be tied directly to the soil. And this, of course, can expand and it can look different in any kind of ecosystem or biome. But the same principles always kind of tied together. There's resources in the soil that live there, the soil itself, and then others that feed on it. And they all kind of decompose back into the circle of life, And then as we kind of move this up to the landscape level, sorry if it's a little grainy here, but I can point things out for you. Let me get a little, okay, well, that's right. All right, so as we look at the top, we see, we have the water, precipitation, and that's where we'll kind of follow this through. Why do we need healthy soils on a landscape? As soon as precipitation hits that soil, we are at risk for surface runoff, a lot of which is normal, natural, it's good for the system, but too much is not so good. So below where it says surface runoff here, we see overland flow, and that's what's flowing directly over, fields, the forest, whatever it may be. And that overland flow is where we can pick up a lot of nutrients that we don't want going into our waterways. As we, irrigate and fertilize fields, this is where a lot of that can be absorbed into the water cycle and put into streams and rivers that can cause harm to fish, other aquatic species, oceans, things like that. That's how we have, a dead zone in the Gulf of Mexico, because we're carrying all those nutrients from fields through overland flow into streams, rivers, and ultimately the oceans, which are all connected. And so that's overland flow, and that can also be pulled down through our subsurface flow here. So really the point is that it's really all connected with the water cycle with soil. Evapotranspiration brings everything back up and keeps our groundwater levels predictable and normal. And all of this, it's important to acknowledge that we alter it all. So where the groundwater flows naturally may change as soon as we dig a well or we cut a lot of trees and things like that. So having a healthy soil that is stable is really important to make sure things function as they are supposed to. When we have our unhealthy soils, we're going to see a lot more impact on these systems, especially, the water cycle, which we see. So with that, I think that's the last one before I take us into our little example. So we're going to put it all together. And so for a moment, I want you all to think of yourself as the land manager for your neighborhood park. And so let's review how your management of the soil can impact the park and what you are responsible for. And so on the left here, we kind of have a diagram of all the good practices, and on the right, the poor practices that are going to impact what you see in your neighborhood park. And so, let's say the goal here is to have a little community garden, which sounds great, to feed your local community. And so we see that on the left side, they're able to do that. And so the good practice here is they have healthy tree cover. It's really positive. So not only does that allow more water to go through the soil because it's covered, it keeps it from drying out when it's really wet. It lets it stay moist, so when it rains, it can absorb more, just like a sponge. It also provides water back up to the atmosphere, so it's able to pull in water from the ground water table up through the roots and back out through the tree. So this diagram notes that it keeps the water table at a reasonable level. And on the right side, we kind of see the opposite. So they cleared all the trees, the water table rose because there's no longer anything pulling water out of there. And we also see more overland flow or surface runoff from that area, which causes some other issues further downstream. So staying on the right side of the image, we're having some saline seepage, what happens when water comes up through the soil when it's not supposed to, basically. We see this at the bottom of hills sometimes, and this can happen as well in agricultural fields when they do a lot of flooding. And so soils like to move things down. And so when we push things back up through them, the salts can get stuck on the surface, which is not good for vegetation or really water quality. We like to keep those mixed in the soil. So we see saline seepage occurring there, which can then kind of run into streams. And that excess surface runoff we're going to see on the right side, it's going to kind of cut into our stream. It's going to erode the riverbanks and carry all of that, the salts, the sediment erosion, and any excess nutrients downstream with it. But on the left, they kind of take care of all that, one, by maintaining cover, so reducing that flow, but also they have what I'm going to call here, that little green bar is going to be a little buffer to catch a lot of the sediment and any other things that kind of come off that hill before we get to our community garden. We're able to have a community garden because there's no salts coming to the surface. And then that all kind of protects our little stream, which looks like an empty stream in this graphic, which is fine. We'll call it a seasonal stream. Protects that from accumulating too much water in periods of high flow after a big storm or something like that, and reduces the risk of big erosion to the banks and really the whole body of the stream. And so that's just kind of a little example to highlight, all these things matter, and we can look at them in terms of, our own personal garden, what we want our soil to look like, but also it's important to realize how it plays out on a landscape level and how every little thing ties down to the soil, and lots of the issues we're facing in terms of, water quality, air pollution, things like that, those can still be tied to soil, and soil can still be used and supported and made healthy to kind of benefit these systems. And so that is most of what I have for you all today. I think Mark's going to hop on and go into a little more Project Wild details, but thank you for letting me speak, and happy to answer any questions.
Okay, thanks, Kalina. We'll come back to questions in just a bit. I am going to share my screen, so if you haven't already done so, Kalina, you can unshare yours. All right. Hold on, bear with me just a moment, folks. Okay, and what I'm hoping you see is the shared screen that shows the Project Wild guide and 3 Project Wild activities. Is that what you see, Kalina? Okay. All right. So what I wanted to do is spend a little bit of time to make the connection to how Project Wild activities can help in teaching and learning about soils. Okay, so 3 activities that are typically used with the topic of soils with Project Wild: fire ecologies, or I'm sorry, eco-enrichers, fire ecologies, and food footprints. And that first one, fire ecologies, is typically what educators think of when they think about Project Wild and soils. So eco-enrichers is a middle and high school activity. It's one of our field investigations. And in this activity, students are using a study plot to learn about different types of soil and how that relates to different kinds of habitat. They recognize the significant contributions of decomposers to soil health and to classify soil types. As pointed out today, since plants rely on soil to grow and large species of wildlife rely in turn on plants, healthy soil is a vital foundation of a healthy ecosystem. So students explain how soil helps to determine that type of ecosystem that exists at the study site and in their region in general. And so to do that, they're making observations and comparisons about the organisms found in the soil from different areas. And they organize and interpret their data to draw conclusions about the soil conditions. And so here's a quick little graphic or look at a graphic that students would be using for some basic categorizing of soil types and soil textures. In the activity fire ecologies, like eco-enrichers, it's one of those older Project Wild activities that is more ecosystem focused in the concepts it covers. It's also a field investigation specifically geared for high school students. And it's really an ideal activity if you have access to an area that has been burned and can visit that area, whether it's a prescribed burn or a location of a wildfire. In fire ecologies, students carry out an investigation of a burned of burned and unburned habitat areas to evaluate the positive and negative effects that fire has on wildlife and habitat. And here is a look at some of the criteria students are comparing at different study sites or through different periods, including soil. And then the activity I really wanted to dive into a little deeper today is food footprint. And this one is a less known Project Wild activity for a few reasons. It is not as much diving directly into ecosystem functioning and principles around the ecosystem, although it includes those certainly, but the focus is more on actions that people take to sustain fish and wildlife resources and healthy habitat. And food footprint, as the name suggests, focuses on the food we eat and agricultural systems. So it's a very complex topic. And the method for food footprint is students creating a flow diagram to trace components of food items from their original source to determine the environmental cost associated with each step in food production. And they can then make recommendations for a more sustainable food options. And much of that procedure, that is the flow diagram, is very similar. In fact, you could think of it as really the same kind of exercise as a detailed concept map, a hierarchical concept map in which students are identifying concepts around food production, including soil and soil health. And of all those topics and all of those ways that they explore new areas to research or list their assumptions, the educator can steer it towards many aspects of the ecosystem or what we do to sustain our natural resources. And so it's a good activity if an educator wanted to dive deeper into soil for that reason. So in food footprint, the learning objectives: 1, students trace foods from their source of origin to the consumer. 2, they describe some of the impacts of food production on wildlife, the environment, and people. And 3, they use evidence to construct an argument for options that could minimize negative impacts of food production on wildlife. So here's a bit more of the snapshot. I told you about the method, but it's gives you an idea that we're talking about middle and high school students here, and typically this would be done over the course of at least 2 60-minute sessions. And as part of that main method, where we start to diagram our existing knowledge and our assumptions and questions we need to ask or check on, it also lends itself to that flow diagram if we trace the route of food. But it can be more than just tracing the route of food. It can be organizing our ideas into questions we want to learn more about. So what are the impacts of food production on the environment, on wildlife, and on people? So this is, you can see just the top of this example of what a classroom concept map would start to look like. And as we break it out more, it gets very detailed. If you were able to attend last week's Project Wild Earth Month webinar, this may look familiar. And we applied it last week to talk about energy. But what I'm going to do something similar here is I'm going to start at the top and trace down towards the left side of this diagram to show how it can help organize our learning around soil. And so, for example, some students might be investigating when they're looking at what are the impacts of food production. They might focus first in the general category of the environment, and they might start to label what kinds of things, what concepts make up the environment. Living things, non-living things, climate, land, water, air, and food production impacts the environment And those impacts include on land, which can include on soil. Impacts on soil would affect various things. We know soil is necessary for crops, to feed livestock, to feed people. Crops may be produced with chemical fertilizers. We might then get into learning about, phosphorus, nitrogen, and potassium in soil, or we might follow a different route on our concept map and talk about, well, what about crops used to feed livestock, and how does that contribute to habitat change? How might that result in more food or less food? How might that affect the number of species, the biodiversity? And how does less biodiversity affect our overall ecosystem services, such as how might that impact pollinators? Okay, so there's a lot of rabbit holes to go down and a lot of opportunities to explore and to tie in current events, rich research opportunities for students and educators. And so the directions for this hierarchical concept map are available to anyone at our website, www.projectwild.org, where you can get this set of instructions. And to do so, if you go to the website, www.projectwild.org, it will put you into our larger Association of Fish and Wildlife Agencies website, but this is what the Project Wild landing page would look like. And our first big yellow bar on the right, that's where you can find these types of resources. So if you click on that, you will find a link to any Project Wild activity and the many resources we provide for any Project Wild activity, including for food footprint, as you can see towards the top of the screen. Okay, so if you are interested in learning more about Project Wild, again, projectwild.org. You can also find links to contacting the Project Wild state coordinator in your state and learn about Project Wild professional development opportunities. And the activities that I covered today, they are in the Project Wild K-12 curriculum and activity guide, which is available to educators who take the professional development training. I'm going to stop what I have to say there, and then we're going to look at some of the questions we have. And Elena, as I recall, you had a few questions queued up already. I'm looking now in the Q&A and I don't see any more, but do you want to go ahead with one of those questions?
Let's see. Well, while I'm finding those, Kalina, I have a question for you that I've been wondering. Is it possible, or are we like close to having another Dust Bowl?
That is a good question. I'm gonna say no. Is it possible? Yes, I think anything is possible. I think right now we're looking at a lot more shifting around of agricultural priorities. Right now, cover cropping is really big in the industry, as it has been, but there's been a lot of recent federal money for climate smart agriculture, and there's been a kind of a new push for getting those cover crops on the ground. And I think that is a key player, at least on the eastern half of the United States and in the Midwest, on keeping soils protected from things like the Dust Bowl. I think we're still kind of playing around with what that could look like in the West, where things are a lot drier. Cover crops aren't always the answer out there. So when you don't get a lot of rain, it's tricky to keep that ground covered and keep those crops in the ground. But they're still playing around with options and cover crops that can work, or longer season crops that are I don't want to say engineered, but kind of studied and found in labs. So hopefully not. Trying to avoid another Dust Bowl.
Certainly. One of the questions we had that someone had submitted during registration was about applying some of what they learned today to their own garden or small or large garden area. And I know I'm literally knee deep in doing my vegetable garden right now. But I don't know if you know the answer to this question, but would something like a cover crop be good for us to plant over the winter time?
Yeah, I think the garden question gets really complicated because we usually use a lot of soil additives in a garden. But certainly if you're gardening in, the native soil, you're digging into the ground, I definitely think a cover crop would be really helpful in making that ground more like garden soil and keeping it loose and, luscious and rich of the nutrients and microbes. If you're gardening in a bed with a lot of, like garden soil, I would say it probably isn't a bad idea to have a cover crop. It'll kind of keep it from getting crusted over. But is it worth the hassle? I don't know in a garden on that small scale, but certainly to build that healthy soil community, even if it's not a full cover crop, but planting something in the winter that keeps roots in the ground would be helpful.
Okay. I know I've been experimenting. They have these really pretty cabbage looking things that I've been putting in the winter time. So
Perfect. Yeah, that sounds great.
does anyone else have any other questions they want to put in the chat? Right, I don't think so. Well, if anyone does think of a question, feel free to email myself or Mark, and we'll be sure to get that to Kalina and get back to you. Kalina, thank you so much for joining us today. And I certainly learned quite a bit about soils today. Realized that I had a few misconceptions as well. So appreciate the new knowledge. And
Absolutely.
thank you everyone for joining us today, and we'll get this posted to the AFWA YouTube channel in the next week. All right, thanks everyone.
Thank you.
Thanks, everybody.